Hi, my name is Nathan Losey with Fundamentals of Physics this is August of 2015 for Ms. Corinne Rombach's physics class. My subject for our physics video this week is going to be the static electricity. Static electricity is essentially a charge that's created by an imbalance of electrons compared to the protons in an object or the surface of an object. Of course, any atom is going to be neutrally charged if it has the same number of electrons and protons, because those have opposite charges and balance each other out. So if we add or remove additional electrons from that object, it's going to obtain a charge of either positively charged if it loses electrons or negatively charged if it gains electrons. Electrons can move between atoms, especially the outer layers of electrons can be relatively loosely held. When we transfer the electrons by contact, a charge will build up on the two different objects that are in contact with one another. When you rub the two objects together, which object will gain or lose electrons is going to be based on what's called the triboelectric series. This is a scientific ranking basically of a lot of materials that are in order of their ability to either hold on to or lose their electrons in series. So generally, whichever two objects are in contact, whichever one is higher up on the triboelectric series is going to be more likely to lose the electrons in the contact. So we're going to do a quick elementary school demonstration of this concept. I've got here a party balloon, and the party balloon happens to be quite a bit lower on the triboelectric scale than, say, a head of human hair. So what we're going to see here is that if I rub this on my head right now, some electrons are being transferred off of my hair into the surface of the balloon, causing it to become positively charged, or rather the balloon to become negatively charged and my hair to become positively charged. And we're not getting a real good charge, so we'll try this out a little bit more. Alright, so you'll see there is my hair is starting to stick up due to the charge it's obtaining. And what you're experiencing here with the hair, first of all, is going to be your hair starts to get real messy at this point, because your hair, all becoming positively charged, is causing it to actually start repelling each other, since of course any objects that have the same charge are going to generally repel each other, whereas objects with negative charge, or rather opposite charges, will attract, which we should be able to demonstrate in a moment here. I'm going to keep trying to build up a charge for just a second. And the other process we're going to try to demonstrate, if we'll walk over here to the wall, is that now, in addition to the specifically positive and negative charges being created here, if we now apply this positively charged balloon to a neutrally charged wall, well, my balloon here is not the best at this whole charging business. What should be happening here is that the positive charge will actually repel, or is actually going to bring the electrons to the forefront here. It's basically going to, or rather push them away. Just keep getting that backwards. The balloon should be negatively charged, repelling the electrons and leaving the closest surface of the wall positively charged, which then causes the negatively charged balloon to attract to it. And that it pretty much sums things up. So the static charge, again, that already exists can induce a charge in a surface near it. So just to summarize, static electricity is a charge that's held in an object due to an imbalance of electrons. Those electrons can be transferred by contact, and charges can cause that physical phenomenon like the hair standing up, because of the fact that objects with opposite charges attract and similar charges repel. My personal degree that this relates to is going to be is mobile application development, and the way that this applies to it is that static electricity can damage a number of electronic devices So it's important to know about static electricity to make sure that we don't short out the sensitive devices that we're programming. That should be it for our static electricity demo today, and we'll see you next time.